It's very cold, and also today it's -10. So maybe it's the first time in 5 years to have this kind of this winter. Yes. Okay. So I will just give an introduction to the course, and after that we can go. I will have also maybe today short introduction to machine learning, for example, and after that we will have some project presentations. Um, I mean, in this course there are some goals which we try to achieve, some learning outcomes. So those learning outcomes, for example, we need to have some understanding of the capabilities and the limitations of machine learning, and knowledge of how to formulate your problem to solve it effectively. So if you have a problem, what kind of algorithm which we should select, for example, how the data look like, how can we define the problem, for example. We need to have also some understanding of maybe CNN, RNN, state-of-the-art transfer learning models. This is a core part, in fact, of the course. So we need to try to, understand how CNN works. But also before this, we will go through some basic stuff. So I prefer to start because I mean from our lecture last time, from our discussion last time, I feel that we need to start maybe from a perceptron feed-forward neural network.
Ibrahim, sorry for interrupting you, but we are seeing a black screen. We are not seeing your
You
slide.
cannot see my screen?
No, it's like a really thin colored line, but we see you, but not the screen you were sharing.
Okay, so I need to share it one more time.
Yes.
So can you see it now? No?
Yes, we're seeing the learning outcomes.
Okay,
Yeah.
okay. So learning outcomes from the course, we need to get some understanding of capabilities and the limitations of different machine learning algorithms. We need also to have some understanding of CNN models, recurrent neural network, and some state-of-the-art transfer learning models. The transfer learning is very important because we can use some pre-trained models. There are lots of pre-trained models, and they trained it for different problems. So maybe you can get a model from machine vision and use it in our problem and so on. So it would be nice if we can try to work with if we can try to start working with those models and try to understand the difference between each models. How can we customize it to our problem? Because those pre-trained models, they are trained for some different problems using huge data sets, for example. And for us, we don't have this capability. We don't have the data. We don't have the computational resources. So in fact, it's smart to look into those transfer learning models and try to apply it to your problem. When you want to apply it to your problem, the data set will be different. The images, for example, the size will be different. Number of outputs will be different. So we need to customize it to our problem. We need also to know an effective approach for developing your machine learning pipeline, for example, to work with real-world problems such as machine vision, text understanding, and time series prediction, and so on. So how the pipeline is constructed, this is very important. We need to get some skills required to deploy our models and evaluating the machine learning models, as well as assessing its relevance and the uses of different machine learning models. Documentation is very important. So when you are publishing a paper, people are expected to see something. So we need to know how to do it. For example, is it confusion matrix? Is it type 1 error, type 2 error, stuff like this? The bases required to collect, process, and utilize data efficiently. The basic skills required to select the right platform to deploy your model. Some people prefer to work in the cloud. Some people maybe try to implement their algorithms in an edge device, for example, or a hybrid approach, and how to configure it to achieve the required performance. This is very important because for some security reasons, for example, maybe we cannot work on the cloud, because when you are working on the cloud, you need to upload all your data to the cloud, process it in the cloud. So maybe some people, if you are working with data from patients, from hospital, for example, maybe people will not agree on this. So maybe just say, no, you cannot work on the cloud because we cannot have this kind of risk. Maybe you're making some application for a company also, and you need to collect the data, send it to the cloud. So when you are sending it to the cloud, chances to get hacked and lost, and so this is very complex. So sometimes it's very important to try to maybe use edge devices and process your algorithms or data locally, for example. The ability to document and communicate the results of your machine learning approach. This is very important also. So we will try to cover as much as possible. So the course contents, it's not fixed, in fact, so we can customize it according to the needs of each group. For example, we need to have some groups working in each different field, different areas. And even here in Zoom, for example, we can create some rooms, so each group can sit together and work together in their project. And we will try to customize, we will try to select models which are needed for each group, for example. So we can start by learning modes, for example, it's supervised and unsupervised learning. Maybe this is the most important. Supervised learning, we have data sets, and it's annotated data sets or labeled data sets. So this is very important. Maybe some people, they have data sets, but it's unlabeled, right? So for example, we had a project with Stefan by Vossen. They have millions and maybe billions of images of roads. They scan roads twice in a way, but they don't have anyone to make the labeling process. So annotation, for example. So maybe it's smart to go for unsupervised learning. So in fact, unsupervised learning, it's more stronger, in fact, and more efficient than supervised learning. Because in unsupervised learning, we don't need to waste time for annotating, and also it will be more flexible, right? Because when you train a model for supervised learning, you restrict yourself to a number of classes. But when it's unsupervised, a number of classes is unknown, in fact. So the algorithm should be able to try to explore, try to find and discover more labels which does not exist in the data, for example. So it's smarter, in fact, to use unsupervised learning. Supervised learning, we call it weak AI, but unsupervised, it's strong AI. So when it's supervised, because in supervised learning, the problem is very well defined. We have number of classes, we have specific data sets. We tell the model all things. So in fact, we call it weak AI, for example, but when it's unsupervised, the problem it's not very well defined. Number of classes is not fixed, so it can change over time. So in this case, we call it strong AI. So we need to optimize to minimize, the error and maximize accuracy. When we build a model, we need to define the criteria or the metric which will be used for model evaluation. Should we try to minimize prediction error? Should we try to maximize accuracy, for example? So we need to define the objective function which we need to minimize. And these objective functions, if you will use, for example, learning algorithm, for example, this function should be differentiable. So when it's differentiable, we need to focus on the activation function. Which activation function should we use? We need to select an activation function which can be differentiated, because we need to differentiate it. If you need to use gradient descent, for example, so gradient descent, we will move by step, and this step is proportional to the first derivative of the objective function, right? With each weight value. So this function must be differentiable. So defining the objective function is very, very important, and it's connected with the evaluation metric which we need to use. Some people today, for example, they talk about fairness of machine learning models. Is it fair? So your model, for example, I need to apply for a job, and people are, racist and biased against some groups of people, and this is, we know, all of us know this, right? And if we need to build a model to classify CVs of people and select people for jobs, for example, maybe the system will be biased as well. It's biased because the data set is biased, right? But is there any way to fix this problem, to try to minimize this biasness, for example, in machine learning? Because this is very important. If I trust in my machine learning, I will provide all my information. I will provide my name. Some people, to get job, they hide their name, for example. They change their name because they need to refer to some groups, for example, and we just feel that people are not fair enough, right? And they are biased, and they will not be able to give the job. And this is, I heard stories, in fact, that some people, when they remove their picture, when they hide their names or change their names, they get the job. But if he put his name and his picture, he will not get the job because people are biased. So this is fact. And it is the same way, if people are biased, maybe also machine learning is biased as well. Correct? So is there any way to fix this? So if we train a model to minimize a prediction error, is it possible to build a model also to minimize biasness? So we need to improve accuracy, or we can just say that we have two objective functions here in this problem. we have accuracy, which we need to maximize, or we have prediction error, which we need to minimize, and also we have biasness, which we need to minimize. So we have two objective functions. If we have two objective functions, we can write a new optimization problem, or we can define new optimization problem, which can be solved, for example, using multi-objective optimization, because they have two objective functions and there should be a trade-off. So we can just say that, no, I don't need to achieve maximum accuracy, but I want to achieve maybe 80% accuracy and 40% fairness, or 50%, 60% fairness. So it will be up to the end user to select the trade-off between the two objective functions. So the metric which are used for evaluating our model, this is very, very important. And people starting working on this direction, not only accuracy, because when we train, in this course, for example, we will try to achieve the best accuracy ever, right? But maybe best accuracy ever is not very correct. I don't know if there is any conflict between accuracy and biasness, right? Is it because we learn from data, and if the data is biased, the model will be biased. Maybe the model will be biased because of some variables or some features. So as I told you, you submit your CV for a job. Your CV is fantastic, but your CV consists of of some features, right? So it has your educations, years of experience, and so on. It has also your name and your picture, right? Your background, for example. So I'm from Middle East, for example. So maybe I will not be able to get this job because I'm from Middle East. My name will reflect something. So we will say, no, we will not give him the job. We don't want to work with him. So if we hide name, if we hide pictures, it means we try to ignore some features. And maybe if we ignore those features, the system will be more fair. So as I told you, it's something which we need to think in. Do we need to achieve best accuracy and ignore other variables or other objective functions also? So it could be something like this one. Representing data and engineering features, the dimensionality reduction to overcome risks such as overfitting. This is very important. So when you start working with your model, we need to get our data first. You need to try to visualize your data. You need to understand your data, clean your data, right? Because maybe your data has some missing values. Maybe we have some categorical variables, for example. Maybe, for example, age. So we can classify people into old, young, for example. So we need to replace it with numbers. Machine learning works with numerical values. So we need to replace all or change all categorical variables with numbers, because machine learning, it can work only with numerical numbers. So we need to fix this. Missing values. If you have missing values, it will be a problem, because if you have a feature and this feature is missing for data, for one example, from your data, for example, it will be a problem for my machine learning model. So how can we fix it? So maybe someone will say, okay, I will just remove all this feature, all this column from my data set. So for example, we collect information from people and we have this column of age, for example. And maybe females, they don't like to say their age, for example, and the majority are female, for example. So we can just say, okay, we don't need to have age, right? So we can just remove age. We can remove one feature. Maybe also you have some customers and you ask customers to provide information, and some of them, they are just lazy and they don't provide all information. So I can just delete this row. So in fact, we will deal with our data set as column and row. Column is a feature and row is an example or a customer or someone, right? So if you have too much missing values in one example, you can just delete this example if it's not very expensive to delete it. And if you have a feature and we have too many missing values in this column or feature, we can just delete this one if it will not have some huge impact on the performance. Other way, we can just put some estimates. So for example, I have age and we have 100 customers and I have 10 who are not providing their age. So I can just fill up those missing values with maybe with the average. So I can get the average age and I can fill up those values with average age, for example. So this is so filling up. Fixing those missing values is very important. Feature engineering, for example, sometimes we have features, and but if I will use those two features, imagine that I have a model with 2 inputs or 3 inputs, but it will be very complex. I will not be able to build my model using those features, and I need to generate a different feature. We call it super feature, which will capture more information and more knowledge, and it will make my model more simple. We will have examples later on. So for those feature engineering, because this is There are very nice big, examples, in fact, which will show us the importance of feature engineering. So dimensionality reduction, for example, dimensionality reduction is very important because sometimes we have duplications and redundancy of data sets, for example. For example, if you have age, you have a data set and it has age and years of experience, years of education. Maybe we have some redundancy and we need to delete some of those features. Not all features are very important. We need to be selective. So we can select the most important features, or we can use dimensionality reduction to reduce the size of number of features. And it's very important for visualization at least. So imagine that you have 4 columns and it's data. I'm collecting 4 values, for example, and those 4 values, I cannot plot those 4 values in 3D, for example, because it's 4. So I need to get rid of 1. So maybe you can use dimensionality reduction to reduce it from 4 to 3. So in this case, I can plot my data set, and when we are plotting it, it will be easy to just see the clusters and understand the data set, how the data set looks like. So we can use something called feature selection, or we can use dimensionality reduction. Feature selection, I want to select the most important features, right? You have 10 features, and maybe those 10 are too much. I want to make my model is more simpler. So I can just select 3, 4, 5, and we will see how much those 4 or 5 features explain in my data set, in my problem. So how much information we will lose. Of course, when we are working with feature dimensionality reduction and feature selection, we lose some information, right? We lose something, but it's a trade-off, right? Because if you will use your whole data set, you need to build a more complex model, and when the model is complex, maybe it will overfit. So we need to get some, it's a trade-off. We need to just decide, right? How many features we want to use. If you want to use 5, for example, so there are some techniques for feature selection. I can just select the most important 5 features, the most important 4 features, and I can train my model. And if the performance is okay, it's okay. If it's not okay, you can repeat this process and select more features, for example. So in machine learning, we start with baseline model, and after that, we will fine tune it, right? So dimensionality reduction, for example, as I told you, we try to reduce the dimension of features, so we can visualize it in 3D, for example. We can get rid of redundancy and things which are not very important for us. In dimensionality reduction, we can use, for example, principal component analysis. This is very important. We can train feed-forward neural network for dimensionality reduction. We call it autoencoder. So we can use principal component analysis. Principal component analysis, it's a statistical tool, in fact. It finds correlations, eigenvectors, eigenvalues, and stuff like this. So we can select the most important, we can reduce the dimension of my data set. I mean, in BCA, the number of inputs will be the number of outputs, but we will have some eigenvalues. This eigenvalue will represent how much variation in this direction. So you can just decide, you can sort it in descending order. You can just select, okay, I will select 2, 3, 4, and we will see how much those 2, 3, or 4 explain in my data set. Maybe they explain 80% or 90%. So there is no need to select the whole set. I can just work with a subset of features. This is very important because the model can overfit easily. If you have a very small data set, and if you will build a complex model, the complex model, it means it has lots of inputs, it has lots of hidden layers, right? So maybe the model will be very, very complex. It will be like, super model, and this model, I don't have enough data to train this model. So if you don't have enough data to train this complex model, the model will overfit. So one way to resist this overfitting and overcome this overfitting, try to simplify your model. How can I simplify your model? By simplifying my data, right? Just to simplify your data. So instead of using 10 inputs, I can just use 5 or 4 or 3, for example. So in this case, we can avoid overfitting because overfitting is very, very dangerous problem. This is the most dangerous problem in machine learning. Model evaluations and improvement. After building your machine learning pipeline, we need to evaluate our model. If it is regression problem, we need to use a metric, maybe like root mean square, for example, to just check accuracy. If it is classification problem, maybe you can use confusion matrix, right? And in confusion matrix, we have many things. We have accuracy, we have precision, we have recall, type 1 error, type 2 error, those false positives, false negatives, and so on. So it's very, very important. When you train your model, you need to get those numbers. when you are publishing a paper, you need to get those numbers. Those numbers are very important. Type 1 error, it's false positive. False positive, it means, for example, someone, he does not have corona, and he did a test, and they said, no, you are positive. But he is not positive, in fact. He is negative, but they just give him, assessment as they classified him as positive. So we call it false positive. Maybe they will give him some medication. Maybe they will ask him to stay at home for 2 weeks, but he is okay, he is fine. So type 1 error, it's no problem, type 1 error. It's not very dangerous. But the most dangerous one is type 2 error, because type 2 error, it's false negative. False negative, it means he is positive, but he diagnosed, when he did his analysis, they just said, no, you are negative. But he is positive, in fact. So they allow him to walk and to go for supermarkets, to buy stuff, shopping, spread the virus around him, meet family members, and meet old people, young people. So this is very, very dangerous. So type 2 error is very, very dangerous. In this course, I will start with a perceptron, because the perceptron, this is a basic unit in an artificial neural network, and we need to understand it, because this is a basic unit. If we understand it very well, the rest will be just easy. And the perceptron also, it's very useful, in fact. So if you are working in a regression problem, you can solve it using a perceptron. You don't need to go for deep learning. You don't go for something complex model if you can solve it with a perceptron. This is a basic unit in artificial neural network, and it's very powerful, in fact, very, very powerful. It's like regression models. And this perceptron, we can use it for regression. We can use it for classification. It can be used for solving really very complex problems. And as I told you, you don't need to go for complex problems or complex models if you can solve it using simple one. So we will talk about a perceptron. We will talk about the optimizer of the perceptron. It's called the perceptron learning rule. Perceptron learning rule, it's 2 lines which are used for training a perceptron. So the code is very simple. For perceptron learning rule, it's just 2 lines. How can we update weights? How can we update bias? So the perceptron has some parameters. Those parameters are weights. When we have inputs, those inputs are connected with the perceptron by weights, right? And also it has something called the bias. So we need to update, we need to train, when we train the perceptron, we need to adjust weights and we need to adjust bias. How can we do this? Using PLR. PLR, it's very simple, and as I told you, it's just 2 lines. We will also talk about artificial neural network, feed-forward neural network, for example. And of course, if we will talk about feed-forward neural network, we need to talk about error backpropagation. We use error backpropagation for adjusting, for training feed-forward neural network. Error backpropagation, it's based on gradient descent. So we will study gradient descent quickly, and then maybe if you want to implement error backpropagation or not, we can just go through it quickly. How can we train deep neural network? We will just have examples, models. We will talk about CNN, RNN, and some transfer learning models, and how can we use it for solving the problems, how can we train it, and so on. And I hope if we have time, we can talk maybe about GPUs, cloud computing tools, and stuff like this. So, a reading list, the most important, in fact, the first 3 books, maybe the third one is very, very important. It's called the Deep Learning for Vision Systems. This one is very, very nice one for people who are interested in machine vision. The other books are nice. All of them are very good, in fact. So, maybe before buying it, you need to check if those books are available in maybe as a PDF, maybe. Because some of them, in fact, I searched for some of them, I can find it as a PDF file. Of course, it's not correct, but maybe it's quicker and it's cheaper. So we have a book called Feature Engineering. This book is very nice. It's about feature engineering. It describes all things about feature engineering. This book, which is Deep Learning for Vision System, this one is very, very good one. This one. Yes. So this is the link for the course. This one, it is a link for the course. We will have a GitHub where we will put. This GitHub, it's for machine learning from last semester. We had a course in a master course called the machine learning. So we have all code which has been done during the whole course, and maybe the slides are there. If it's not there, I will try to upload it to the same place also. And during the course, I don't think that you need to get some data from somewhere, because you are working in your PhD and you have already your own data sets. I mean, there are some data sets everywhere. There is also IEEE repository. I didn't put it here. It has very nice data sets which are used in, I mean, like deep fake news. And so there are lots of data sets. I mean, if you need a data set, it's not a problem. And I'm sure that in your project, you have already your own data set, which you will play with. I mean, this is Blackboard also. I will try to update Blackboards each week, for example, so I can update, I can upload, for example, I can write some announcements. So if there is something, I can write it here. And also here, we have something called about Arbadas graph. Maybe this one about home assignment. And this one also under versioning material. This is the course material, it will be here. So this one here, we will have course materials. And if we will have a home assignment, for example, or something, we will put it here in this Arbadas graph. And I mean, this is the course participants. I guess you know each other, all of you know each other. So maybe we have Mingtao, we have Lena. Lena, she will not be able to attend each week because I mean, she is very busy. So she will try to follow up with us, I mean, by internet and by, I will send all links, I will send recordings to her. We have Rasmus, we have Ola Magnus, we have all people. So we will try to find a way to classify us so we can work in clusters, right? So people who are working in time series, they can work together. People who are working in natural language processing, maybe they can talk to each other. People who are working in machine vision, maybe they can discuss with each other and work together, get support from each other, and so on. I prefer to work in Google Colab, but it's up to you to just select. So Google Colab, it's a free and open source environment for Python development that requires no setup and runs entirely in the cloud. Very easy to use, in fact. So if you want to work in Google Colab, it's very easy, and it's easy to just share it with everyone, right? And we can use a GPU and we can use a CPU, in fact. So when you are writing an example, you can just select, I want to run it in a GPU. And when you select a GPU, you will get this Tesla T80 GPU. You will get this one. But it's easy to work with because you don't need to do anything. You just need to open it. It's web-based. You need just to have a Google account, for example, and just start working in Google Colab. And it's easy because you can share it with maybe your supervisor, for example, your friends. You can share the code with them, and it's based on this Jupyter notebook. So it's the same, in fact. But it's up to you to select. It has all those pre-installed packages, such as Keras, TensorFlow, PyTorch. All those are already there. You don't need to do anything, in fact. So I feel it's much easier for me because it's like safe. I mean, it's a peace of mind, for example, because I don't need to worry about any other things. I can just work in Google Colab, but it's up to you to select. So last semester in the master course, we used this Google Colab, and we uploaded. It was easy even to upload all code automatically to GitHub. So just upload it automatically from Google Colab to GitHub. So maybe if you want to create a GitHub for your PhD work, for example, you can just put all the stuff in the same place. It will be more safe. Yes. So there are some examples. So if you want to have some introduction to Google Colab, for example, you can just use this one. Lots of examples. You can start with some example plotting something, for example. So for example, here it's just an exercise. For example, if you want to do this one, do you know this data set? It's IRIS data set. IRIS data set, it's a data set which was collected in 1936. And this data set, it has 4 attributes. We have 4 attributes, which means 4 columns. As I told you, the data set will be like number of columns times number of rows, for example. So, or number of rows times number of columns. Those rows are examples. How many examples we have in our data set? So this one has 4 attributes, and I guess it has maybe 150 examples. It has 150 examples. And we have 4 attributes. We have here sepal length, sepal width, petal length, and petal width. And finally, we have target feature. So this one we call it target feature. So this is the one which we want to predict. We want to classify, for example. So for example, you have this example, and this example it's Setosa, IRIS Setosa. We have 50 examples in each cluster. We have 3 clusters. So in this data set, in fact, we have 3 clusters, and it's called Iris, Setosa, Versicolor, and Virginica. And do you see here, we have A, B, C, D, or we have 4 features. So we call this one input feature. This one, it's input feature. So, so my data set consists of number of input features and a target feature, right? We have 3 classes. We have 150 examples, right? And this is very basic problem with people who use it in machine learning. It's just maybe like Hello World, for example. We can use, for example, here a perceptron to classify this problem because we have 4 inputs. So, for example, if I need to use a perceptron, it's just I will use a perceptron is a circle, and this circle has number of inputs. In this case, we will have 4 inputs, correct? And we will have 1 output. The perceptron, it has only 1 output, right? So in this case, we cannot classify many things. We use perceptron for binary classification, right? So we have a class. Is it positive, negative, yes, no, for example? So in this case, I can just maybe select the first 100 examples. So I can select the first 2 classes, correct? So maybe this one, I will just say, as we mentioned before, when you process your data, we need to convert those categorical variables into numerical. So maybe I can just replace each Iris Setosa by 0 and each Versicolor by 1, right? So now we converted it into this problem. So in fact, I can use a perceptron for solving this problem. So I will have here 4 inputs. It's A, P, C, D, for example. We have here something called, we call it bias, right? We have some weights, omega 1, omega 2, omega 3, and omega 4, right? And I can just use a perceptron for solving this problem. So perceptron is very, very important. This problem, it's multi-class classification. It's not binary classification, because in binary classification, we know that we have 2 classes. For example, I want to get loan from the bank, right? So maybe it's a binary classification problem, which means it's yes and no. Maybe the bank will give me a loan or will not give me a loan. So it's binary classification. You have a picture, for example, and it's cat or not cat. It's cat or dog. So we have a data set called dogs and cats. So you have a picture, and you need to classify it. Is it dog or cat? So it's a binary classification problem. In this problem, in this Iris data set, it's a multi-class classification, which means we have 3 classes. We have Setosa, we have Versicolor, we have Virginica, right? So it's a multi-class classification. Multi-class, which means we have more than 2 classes. We call it multi-class classification. The perceptron, we can use a perceptron for binary classification. We can use a perceptron for binary classification, not for multi-class classification. We can use it in multi-class classification. In fact, we will learn how to do this. But it's a simple trick, in fact, to use a perceptron for multi-class classification. Because, but we will talk about it. So in this case, the first point here is to plot your data set. We can plot A with B. Do you see? We have 4 features. So I can just say, okay, if I don't know if I can, I just need to create a new slide, right? Empty slide. So I can just plot. So for example, we have A and B. So I can plot A with B, right? And maybe I can plot A with C. I can plot A with D. I can plot B with C. So it will be hard for me, in fact, to understand how the data looks like. So one way to simplify this data set, I can just use BCA, for example. So the BCA will consume those 4 inputs, and it will try to reduce. Maybe you can just say, I need 2. I want to solve this problem with 2. So I will ask the principal component analysis to give me the most important or the principal component, two principal components, right? And I will solve the problem using the reduced set or the 2 components. So we will have lots of examples. We will use principal component analysis. Also, we will try to use autoencoder, because autoencoder it's a nice tool, right? Because it's feedforward. It's not statistics, in fact. So it's apart from the machine learning domain. So I can use an autoencoder, and the autoencoder consists of encoder and decoder. And after training it, I will use the encoder to reduce my data set, for example. I can use also the autoencoder for denoising, right? as a denoising for reconstructing an image. So for example, you have some image or you have some image plus noise, and I want to train the model to remove noise from the image. So we can use autoencoder for the same task as well. Yes. I mean, finally, how you will run your algorithm, how you will train your algorithm. Is it locally or in the cloud? Right? So in fact, for prototyping, it is supposed to be done maybe locally because it's cheaper. So you need to build, train, and deploy your machine learning models quickly, and it requires massive computational resources, especially if you have big data sets. So if you have videos, for example, you can just imagine what is the size of your video, how much data you have, right? So you can just say, okay, how is it possible to use GPU, for example? Should we use it in the cloud? So you will need fast enough GPU to do deep learning experiments locally for maybe simple data to verify many things before going to full scale on the cloud. I mean, it's preferred to run your algorithm on the locally in your local GPU, and after that you can move it to the cloud because you need to avoid problems, mistakes, and stuff like this. So at least for prototyping and to be sure that all things are working fine, and after that you can move it to the cloud. In the cloud, we have lots of services. In fact, we have Amazon Web Services, we have Google Cloud, we have IBM Watson, we have Microsoft Azure, we have Alibaba. So we have all those approaches. For course assessment, you are a PhD, so don't worry at all from this. Just forget about this course assessment because I hate exams personally. I don't like exams, so don't worry about the course assessment. We need the course to be productive. This is the most important. So if you have a report, good report from the course, it is very enough, right? So the most important is to try to use most of the course and to use the time in a nice way and in a wise way to write a report which can be published. It's not very important to publish it before the end of the course, for example. I mean, later on you can publish your report and you can modify it, maybe repeat coding and stuff like this, polishing your code and publish it. But we need a report, and this report should be based on a project. And this project, it's from your selection. You need to select a project related to your PhD, but it should not be part from the PhD because I want you to get the feeling that we are doing something different. Just to be, because sometimes we need to be away from the PhD work, right? So if it will lead to a publication, extra publication in your PhD, if you will work with someone else and make a good publication together, it will be nice. 2-3 persons together will write a good publication at the end. It will be very great achievement. So the report, it's not a problem. And the grading, I mean, to pass, it's 70%, more than 70, because it's best in the field. I mean, for PhD, we don't have grading, we don't have A, B, C, D, but it will be just pass and fail. And I hope all people will, of course, will pass. Yes. Yes. So do you have any questions?
I have just one comment regarding the Blackboard site. I don't think you've opened any of the views for us, so I can only see the collaborate link there. So you have to unhide the Pensum and.
Yes, in fact, I didn't upload anything yet. I just wrote some announcements in Blackboard.
Yeah, okay. Because you see all the pages on the left are hidden, so we can't see them.
This one is hidden. So
yeah, so you see beside like information on an arbeidskrav, just this little square.
Yes. No, you just need to select the course name. It's DT 8007. This is the course, and when I select this course, you will just get this window.
Yeah, but all of the pages are hidden for us. It's only you as an instructor who can see the links to arbeidskrav and pensum and undervisningsmaterial.
Oh, you don't have all those?
No, so you have to unhide them.
Okay. Maybe I will check if I did.
I think it will become unhide itself when he uploads something in that box.
So do you think I did some mistakes or in Blackboard?
I think once you put something in Undervisning, it automatically will come in our Blackboard. So
okay, so I can try. For example, now I can upload. For example, I can upload this slide. For example, You can upload the slide and check. You can just check. So build content. I will just maybe create a folder for slides. Yes. And in this one, I will upload maybe one PowerPoint.
Yeah, I can see there's a new folder there right now, so it seems to work like that. Yeah.
Okay. So I will just put one PowerPoint. Okay, I uploaded one. You have something now? Can you see something?
Yeah, there is one PowerPoint in the slides folder now.
Okay, so it works.
Yeah.
Yeah. So Ola Magnus, can you see it?
Yeah, it's there now.
Okay. So I guess maybe you can take some short break, and after that we can go back to. I have also some, few slides. We will do it, and after that we can take some projects. Is it okay? Yes. So how much time do you want for break?
10 minutes.
10 minutes. Okay, this is fine. So we will meet again at 9:55.
Yeah.
Thank you very much.